All right, so let's take a look at the two examples on the back. I think it's important to emphasize that this style of dependence and independence testing is really how probability is often taught in the real world, or how it's often used. In class, we're often given some problems and then we're asked to find a probability. But when probability is used in the real world, more commonly, a researcher is collecting data and getting the actual experimental probabilities. And they're using that to determine whether two events or characteristics are dependent or independent. For example, is getting COVID and wearing a mask, are those two events dependent or independent? Well, you would gather data on getting COVID, you would gather data on wearing masks, then you would gather data on getting COVID and wearing masks. And with those three pieces of information, you can determine whether or not the two probabilities or the two events are dependent or independent. So let's take an example. Example A here in the notes. Mr. Ruth thinks that whether people smoke has nothing to do with whether or not they are afflicted with cancer. This isn't actually true. He studies the probabilities in the media and finds the following, right? He says the probability that somebody is a smoker is 0.3. And that used to be true. A lot of adults used to smoke in the United States. The probability that somebody is afflicted with cancer in their lifetime is 0.4. And they check what's the probability that somebody is both a smoker and afflicted with cancer, and he finds that that's 0.2. Now, with these three pieces of data, we can figure out whether or not these two events are linked in some way. That doesn't tell us causation, but it does tell us association or correlation. How? Well, imagine that these two things, smoker and cancer, were independent. If they were independent and we drew a Venn diagram, right, then we would know when two things are independent, then the intersection is simply taking the two probabilities and multiplying them together. So if I multiply 0.3 times 0.4, I get 0.12. That's what I would expect if smoking and cancer had nothing to do with each other. I would expect the probability that somebody is a smoker and has cancer to be 0.12. But what is it based on what I see in my experimental data? In my experimental data, it's not 0.12. Instead, it's 0.2. This is greater than this. That tells me actually smoking makes it more likely that you're going to have cancer, or having cancer makes it more likely that you were a smoker. That's what we see in the data. So these two events are not independent. Mr. Ruth is wrong. They are dependent events. Put another way, without doing the Venn diagram, the question is this: is the probability that somebody is a smoker and has cancer the same as the probability that somebody is a smoker times the probability that somebody has cancer? This right here is the 0.2. This, the probability that somebody is a smoker, the probability that somebody has cancer. And this is a question. I'm not saying these things are equal. I'm asking the question, are they equal? Well, over here, you can see you get the 0.12. Over here, you get the 0.2. They are not equal. And when things are not equal, they're dependent. Example 2. John thinks that whether or not you like basketball depends upon whether or not you were born in the first 3 months of the year. He surveys the whole school and finds the following probabilities. The probability that somebody likes basketball is 0.2. The probability that they're born in the first 3 months of the year is 0.25. And the probability that they like basketball and were born in the first 3 months of the year is 0.05. Now, he didn't calculate any of these numbers, right? I mean, he just polled people like in the cafeteria, in the hallways, and he gathered the data, and this is what the data told him. So the question is, are these two things independent or dependent? Do they maybe correlate or associate with one another or not? Well, the probability that somebody likes basketball and born in the first 3 months, is that the same as the probability that somebody likes basketball times the probability that they were born in the first 3 months? Well, this probability over here, the and probability, is 0.05. These two probabilities, probability they like basketball, 0.2. This probability is 0.25. When I do the math over here on the right side, I find that this times this, in fact, is 0.05. These things are equal, and if they're equal, they're independent. Now, in the real world, we don't demand exact equality. We want the two numbers to be reasonably close. The further apart they are, the more we're convinced that they're dependent variables. The closer they are, we suspect they're independent, and maybe the slight variations are due to random chance.